In this video, we're going to learn how to find missing side lengths in a right triangle using a trig function. Now, just to remind you, the three trig functions we talked about were sine, cosine, and tangent. Sine, cosine, and tangent, we use the saying so, ka, toa to help us remember what the ratios are for each sine, cosine, and tangent. It's also very important to remember that if you're writing an equation, let's say for sine, it needs to be sine of an angle equal to a ratio. So inside the trig function, you need to put an angle. And in this fraction, there needs to be side lengths. That's the basic setup for any trig function. That could be sine, cosine, or tangent that are written there, but you need to have this set up as a trig function with an angle inside of taking the function of it, and it's equal to a ratio of side lengths. First thing you should do when you're looking at this problem where you have to find a missing side length is label the side lengths given to you. So we have a 60-degree angle right here. Across from that is the opposite side length, x. Across from the 90-degree angle is a hypotenuse. And 16 is going to be then our adjacent side length. That's the one next to the 60-degree angle. Okay, we have x and 16 and 60 given. In our setup, it's going to be trig function of an angle 60 degrees equal to the ratio of side lengths. The side lengths that are mentioned in this problem are x and 16. That's opposite and adjacent, O and A. The trig function that goes with O and A is T, which stands for tangent. So that's the trig function we're going to use. It's going to be tangent of 60 degrees is equal to opposite over adjacent, O over A, x over 16. That skill of writing the correct trig equation is fundamental to finding missing side lengths. Now, we are looking for x. We need to solve for it. Therefore, I need to get rid of the 16 underneath. And underneath means that it's being divided currently. The inverse of division is to multiply. So if I multiply both sides by 16, x over 16 times 16, these essentially turn into the number 1, which leaves that x is just by itself, like that. On the left side, 16 times tangent of 60. So 16 times tangent of 60 degrees is approximately 27.71 units in length. And you've solved for x. And that's the end of the problem, because you found the missing side length. This next example, you are given a 59-degree angle. Across the 59-degree angle, opposite is 14. Opposite the right angle, the hypotenuse is x. And then the adjacent side length is not given. So we're focused on opposite hypotenuse. That's O and H. If I scroll up back to SOHCAHTOA, O and H right here goes to sine. So I'm going to use the sine function. So sine of 59 degrees is equal to 14 over x. I'm going to highlight the variable x to show you that we're solved for that. Right now, x is in the denominator of the fraction. And when we solve for x, it needs to be in the numerator. So the first thing I'm going to do is multiply both sides by x in order to make x appear in the numerator. And what this does is turn that into 1. And you're left with 14 on this side. And then you have x times sine of 59 degrees on the left side. Now, you are still solving for x. So therefore, I need to isolate it. And we're going to do that by doing the inverse of multiplying by sine of 59. Just a quick mention of this. Sine of 59, this is one thing. You can't split up sine from 59. 59 degrees is inside of the sine function. Okay, they're indivisible. So currently we're multiplying by sine of 59 degrees. Therefore, we're going to do the inverse and divide by sine of 59 degrees, because that will turn those two factors into 1. So I can cross them out. And x will approximately be 14 divided by sine of 59 degrees, which is